So what I'd like to present to you this evening is what I believe to be a unifying nutritional model of modern disease. I'd like to think that at this point in time in life we are searching for an answer because things aren't quite right. We know things are not right with our health. Things are changing and there's something wrong. I suspect that we'll look back on this time and say, why did we do what we've done with our eating for such a long period of time? We now know that you're not going to grab hold of a piece of asbestos and cut it up with an angle grinder because we know that 40, 50 years down the track, there's a slow problem that builds up. We know the same thing with smoking, exactly the same thing, it builds up over time. And so I think the same thing happens with our nutrition. Now, in my early years, I was raised on a combination of sugar, refined carbohydrate and polyunsaturated oils, and I ended up being a fat kid. I had pimples, I was bullied, it was all part of life. At 38, I ended up having a tumour at the base of my pituitary, base of my brain, the pituitary, and ended up needing a whole lot of surgery and management. And I believe that the combination of sugar, and particularly the component of fructose, refined carbohydrate and polyunsaturated oils probably contributed to my situation, both in what I had and in the amounts that I had. And I think they're poison, and I'm going to go and try and explain to you as to why that combination in today's society is a nutritional model of modern disease. How did I get into that trouble? Well, it got me to thinking about the whole process. It got me to make, first of all, the first observation. We got to the top of the food chain over 2.5 million years by eating in one specific way. And we've been on a fad diet for the last 60 years and certainly the last 30 years. And in that same time frame, we've gotten sicker, we've gotten fatter, we've got major metabolic problems. So modern disease is upon us. Every condition we know is increasing in incidence and severity, and younger people getting it, whether or not it's cancer, whether or not it's liver disease, kidney disease, hypertension, dementia. Everything is on the increase and affecting a younger population. Always tried to work out why skinny people still get heart attacks, strokes, dementia and cancer. And they're called toffees. This is a condition where we're thin on the outside but fat on the inside. We've actually got metabolic disease happening on the inside even though we're not overweight. And it's estimated that 40% of people who are skinny, who are thin, actually are metabolically quite deranged on the inside. This is coming at an enormous health and personal costs to society. If you look at the economics of it, everything you look at, and we did a paper about 3 years ago looking at the economic costs of looking after well diabetics in Australian society. We will spend the entire Australian health budget looking after well diabetics within 20 years. That's not any complications, not any heart disease, not any ulcers, not any strokes. We'll spend just that looking after it. And it was suggested that our data was in fact a bit biased, but we actually modelled it on 40% of the expected number. So clearly not biased. We actually underestimated it, and we're going to go bankrupt just on our cost of diabetes within 20 years. Forget any other conditions. The trouble I see with medicine is it's very reactive. And as doctors, we tend to see patients, they come along with a problem and then we treat the problem. We're very rarely to actually go back and look at the root cause of it. And if you look at the root cause, often that's where it's all entirely preventable. And we need to go back and look at the start of all these conditions. And I think, therefore, we need to look at history. And that history, I think, starts with that Palaeolithic age. For 2.5 million years, we've been evolving to our environment and eating the right way, and has allowed our metabolism to travel that path. And a lot of the ideas that I'm putting up here tonight are actually almost based on anthropological biochemistry, how we have evolved to survive in that environment. As a hunter-gatherer, our food sources were local, seasonal and natural. All pretty basic. We ate by the seasons. In summer, when fruit and a few grains were available, we used to store that for fat as it went into hibernation. Very simple. And for the other 10 months of the year, it certainly wasn't available. So in those times of plenty, we'd eat our seasonal fruit, what access to honey we would get, remembering that's in a beehive guarded by bees, and it's actually only made for a few months of the year. We'd eat a few grains, which you'd actually collect off the ground, and that's carbohydrate, and we'd turn that load of, as it turned out, fructose and carbohydrate into fat for winter hibernation. We still do that with animals. If we find that fat in an animal, we feed it grain. And it's only accessible as a hunter-gatherer or in nature for animals for a couple of months of the year, maximum. End of summer, beginning of autumn. The rest of the year we'd eat whatever animals we could catch, whatever insects, root vegetables, nuts, maybe a few eggs. And our very first meal that we had, in fact, was breast milk. So having dairy in our diet is actually a natural thing to do. And lactose intolerance is, in fact, a newish condition, and it only comes about if you lose contact with dairy in your diet. So if you have milk as a baby and you continue to have dairy, you keep producing lactose. And it's if you have a couple of years off from that, then you actually lose that lactase, and then you reintroduce dairy, then you get your lactose intolerance. So that food, we need to know what happens to it. So that fuel source is effectively turned into energy in our mitochondria. That's a big part of it. You've got the cell here with the cell membrane. We'll come back to that. And these little powerhouses are called the mitochondria. That mitochondrial engine is in fact a hybrid engine. It can run on two fuel sources. One is that summer carbohydrate of fructose and glucose, which is our carbohydrate. And that's what we run on for a couple of months of the year as a hunter-gatherer. The rest of the year, it can actually run on a second engine, which is actually fuel. The fuel base is fat. Most of us in the room have never turned on our hybrid fat engine. Most of us from the day we were born have been actually running on that carbohydrate engine, sugar, carbohydrate, and never actually turned on that diesel, fat, very efficient engine. So we've got a choice here. We can run on the diesel fuel of fat, or we can run on unleaded high-octane fuel of carbohydrate. Where does that high-octane carbohydrate come from? Traditionally, as a hunter-gatherer, it would come from seasonal fruit, which is available for a couple of months a year, those grains, and that small amount of honey that you may be able to harvest in a short period of time for that couple of months. For the other 10 months of the year, you'd run off the fat that you stored over that summer period, or you happen to get access to meat, some dairy, some nuts, or some eggs again. So we do have a hybrid engine. We can run on two sources, carbohydrate or these fat-based fuels on the right-hand side. Now, about 10,000 years ago, we started mucking around with our system. We had domestication of animals, and we started cropping. We started grain cropping, and those grains were full of fibre. And then we had the industrial age for the last few hundred years, where it all became about efficiencies. Following on from that, we then developed the modern age. And that modern age is all about convenience. It's actually about driving costs down, mass production of crops, and it's all about profit. And we're actually all to blame for that, because we all want something which is cheap, tastes nice, and has a long shelf life. And the food industry have provided that for us. 1950s, we had the development of fast foods, takeaways, and that's all on the increase. So as a result of that, our food industry responds to the market. And what they did is they introduced sugar in significant quantities, took fibre out of our food, and introduced polyunsaturated oils, all about improving shelf life, transportability, and driving costs down. We know sugar's a great preservative. The more sugar you put in something, the longer it lasts. You know that if you get a piece of grain bread, it will last a certain period of time. It's mouldy within a week. You take the grain out of it, you put a bit more sugar in it, you've got white bread that'll last longer. Then you've got raisin toast, which is going to add to the sugar content, and that will last for a few weeks. And then you've in fact got your Christmas pudding or your wedding cake, which is full of fruit and sugar, and it's meant to be there for your child's christening, so you can still eat it a couple of years down the track. All we've done is increase the sugar content. We know that fibre in food equals mould, and by taking it away out of it, it improves that shelf life again, and that drives down cost and improves profitability. Polyunsaturated seed oils, vegetable oils, which in fact vegetable doesn't actually produce an oil, it's colloquially termed a vegetable oil. That's all about marketing. Seed oils are commercially produced, harvested, and they're much, much cheaper to produce than the harvesting of fat from pigs for lard and in the butter production, which is a lot more labour intensive. So as a result, our modern food, which is told to us that it's natural, I don't think is natural. I think it's specifically manufactured for our current diet. So with that modern food, I think we've had the development of modern disease. And if you get to the root cause of modern disease, it's all about inflammation. Every single condition at its root cause is related to inflammation. Now that affects cancer, cardiovascular disease, dementia, autoimmune diseases, and particularly diabetes. So if we can get to the cause of inflammation, maybe we can start getting to the root cause of all disease. So I believe our diet is toxic. It is the thing which is the major contributor to our inflammation, and that inflammation is ongoing and increasing. So in a nutritional model, I believe that the fructose, the refined carbohydrate, which is in fact glucose, and the polyunsaturated oils together create inflammation in every blood vessel wall and every cell membrane in every organ of the body. It's encompassing, it affects everything. And I'm going to try and describe to you the mechanisms of how that occurs. So what are our culprits, okay? Sugar is half glucose and half fructose. Very similar chemicals, same number of carbon atoms, and the only difference is they're shaped slightly differently, but they're metabolised quite differently. Sources of fructose are natural fruit, natural honey, but in today's society, that other sources are in fact manufactured fruit. The fruit's manufactured now with less fibre and more sugar to improve its shelf life. There's nothing natural, I believe, about a banana in Tasmania. I don't think there's anything natural about having apples all year round at the supermarket. I don't think there's anything natural about getting sugarcane, harvesting it, crushing it in a mill, bleaching it, colouring it, and then calling it natural. And high fructose corn syrup, which is not a lot in Australia, but certainly around the world is in fact getting corn, turning it in a laboratory into high fructose corn syrup. None of that's particularly natural, and certainly not the amounts that we're consuming nowadays. Now, one thing took me a long time to learn, but carbohydrate is just glucose. It's just repeating molecules of glucose all tied up. And it doesn't matter if it comes as glucose powder, it doesn't matter if it comes as starch, and whether or not that's bread, rice, pasta, potato. It's all just glucose. And the other half of sugar is in fact glucose. So we have a massive glucose load in our current diet. Polyunsaturated oils, traditionally that's margarine, which is marketed to look like butter. And you've got the seed oils. And again, marketed as to look like vegetable oil, called vegetable oils. Whether or not it's canola oil or sunflower oil, they're all the same. So the difference between fats and oils is in fact what they are at room temperature. They're actually the same molecule, but a fat is solid at room temperature and an oil is liquid at room temperature. Now, fat in general we'll call butter, which is the easiest way to think about it, and it's solid at room temperature. And most of our saturated fat in our body is liquid at 37 degrees, which is our temperature. The thing about oils is that they are in fact liquid at low temperature, and a plant needs an oil to actually transport its fuel up and down a stem at low temperature. And at low temperature it requires flexibility. And that flexibility comes at double bonds within the side arms of that oil. What does that mean? Well, at each double bond, that's a point of weakness. It's a point of flexibility, but it's also a point of weakness, and that can become oxidised. And if it becomes oxidised, that's the same as something rusting, and that's an inflammatory process. So therefore, double bonds within a fat expose ourselves to inflammation. So in this nutritional model, if we combine all three of these, that in itself gives us inflammation, but then other stuff has to occur. That other stuff is a variety of things which I think affect our bodies when we've in fact got in an inflamed state. And that involves a whole lot of processes. It involves vitamin D, stress, genetics, if you've got a predisposition to that, chemicals, bowel organisms, gut flora. There's a lot of work being done on that. Exercise. I think that diseases change by latitude and longitude. Sleep plays a role. Sedentary behaviour, and even artificial lighting has been implicated in modern disease. So let's go through the biochemistry of how that inflammation occurs. I'm going to keep it simple. Okay, I'm an orthopaedic surgeon. I like lots of pictures. We're not going to go into great depth, but we're going to go into principles. The first thing to think about is to think about the links between hibernation, starvation, and obesity. It's hard to think that they actually completely related, but they are, and it's important. I appreciate the work of Rick Johnson. He's from Colorado, and he's loaned me a few of these slides. And Rick is a renal physician. He's done a lot of experimental work into this topic. And he's written a book called The Fat Switch, which is well worth recommended reading. But our fat is protective. The more fat you can store for winter hibernation, the longer you will last. And in fact, storing fat for winter is in fact scheduled or programmed obesity. It's actually a very deliberate attempt by nature to program us and schedule in getting fat. We then store that fat in the period when the food has stopped, and then we in fact burn down those stores. That's an important thing. And that's the difference in Western society. Our food actually doesn't stop at the end of the summer cycle. But in nature, that food stops. So an animal will in fact store fat for winter hibernation, and then it goes into a period of starvation. That's hibernation, it's starvation. And in starvation, whether or not you start starving yourself right now, the very first thing you'll do is you'll burn down your glycogen stores in your liver. That's your instant energy sources. After that, you start burning fat in your body, and you slowly burn that off, and we're quite calm and relaxed about that, and people on starvation diets actually don't get particularly agitated, they're fine. But the moment you start running out of your fat stores, you start burning up protein. And the moment you start burning up protein, you're in strife. You start producing some metabolites, and those metabolites are in fact cortisol, which makes you agitated, and uric acid. That's the byproduct protein breakdown. And if that continues on, then you end up dying. That creates a state of agitation and foraging, and that's perfect, because if at the end of hibernation you need to wake up because you're running out of fuel, and you start doing that. And Rick Johnson gives a very elegant discussion, and that's what an emperor penguin does at the end of its egg holding period. Its fuel stores drop down, and if the egg hasn't hatched, or if the female hasn't come back to that male on the nest, it goes off because it's finally reaching that point of protein breakdown. Now, how does that link in with this nutritional model of modern disease? The interesting thing is that the same products that are produced at protein breakdown are also produced in sugar breakdown that create this situation. Now, we're going to quickly go over metabolism of these few things. We're going to talk about metabolism of glucose. Remember, glucose comes from carbohydrate. It comes in the form of starches, our breads, our rices, our pastas, and in the forms of maltose or lactose in breast milk, and dextrose in a variety of other substances. That glucose comes into your diet, immediately gives a blood glucose elevation, and that blood glucose provokes a bit of an insulin response via the pancreas, and that insulin will help drive that glucose into muscle, a bit into the liver. There's always a maintenance of glucose supply to the brain, and there's any extra goes into fat production. What's interesting about glucose is that we produce a normal background amount of glucose, and it's only when we eat that we bump our glucose level up in the blood, and then the body's got to respond to that by putting insulin in. And that happens when you have a carbohydrate load in summer. I keep coming back to that, but if you run on that fat metabolism, you're never actually driving glucose in. You're never needing to push up your insulin levels dramatically like you do in the situation of putting glucose straight into the bloodstream. What the liver does with glucose, under the effect of insulin, it restores its glycogen stores pretty well straight away, and the extra goes to fatty acids. Now, to simplify that down even more so, if you have refined carbohydrate, which is glucose, under the effect of insulin, it goes to fat storage. And we'll keep it as simple as that. The other half of sugar is fructose. This is the latest enemy number one for the world. You're starting to hear about it, and I'm going to try and explain why. Fructose runs through a whole lot of interesting metabolic pathways, but ultimately, the one I'm interested in today are the low-density lipoproteins. They're what's called the bad cholesterol. You might have heard of LDLs. You've got a variety of them. They're all little lipoproteins which transport fat and protein around the body. But if they're particular sized ones, the low-density lipoproteins, which are the small and dense, they're in fact the troublesome ones. And we're going to go through a little bit of fructose metabolism very quickly. Fructose is absorbed in the gut very quickly. And in times of starvation, we don't have many receptors, but in the time of plenty, our receptors jump up almost exponentially, and we can absorb as much as we can. And Mother Nature's given us that potential to store as much carbohydrate, store as much fructose as it can in that time of plenty. Complex metabolism here. I thank Robert Lustig for this slide. And we're going to simplify it down. Fructose comes into the liver, and it travels via a whole variety of pathways. A little bit of it goes off to restore glycogen, stores in the body, but most times glucose will do that very quickly. We know that if you ferment fruit, you turn it into alcohol, and the liver does exactly the same thing with fructose, and it has an aldehyde pathway. And if you have too much fructose over time, you in fact start getting liver disease. Little known fact about fructose is ultimately the byproduct of that is uric acid, normally associated with gout, and in Western society, we've had a doubling of gout in the last 10 years, despite the fact we're having less alcohol intake, less red meat, which is normally associated with gout. So fructose, through a complex pathway, in fact ends up as uric acid. Remember, this is the same uric acid that is produced when you're starting to break down protein at the end of starvation. And the body doesn't care whether or not it's protein breakdown producing uric acid or fructose causing uric acid. Both of those are going to drive us into a state of agitation and hunger to force us to have more food. So what does uric acid do? Uric acid has a variety of effects, but it affects this thing called nitric oxide. Nitric oxide, there are three forms of it. One of it is involved in maintaining circulation and blood supply to the brain. Another one is involved in maintaining our blood vessels at the right sort of vascularity and tension so we keep our blood pressure fine. And the other one is there's a form of it which is involved in our immunity, both from an infection point of view and a cancer point of view. So if we interrupt that normal control of uric acid, normal control of nitric oxide by producing more uric acid, it inhibits all of these pathways. At the brain, it's therefore implicated in the cause of dementia, in the cause of mental illness, and in our blood supply. If you inhibit nitric oxide, it's associated with hypertension, and if we inhibit it at our defence mechanisms of our immune system, it's implicated in infection and in cancer. The other effects of fructose, by a variety of pathways involving free fatty acids and nitric oxide, is it creates insulin resistance in the fat in the liver. It also affects leptin. Leptin's a hormone produced by our fat, which actually tells us in the time of plenty that we're not hungry. That's why you can actually lie there in hibernation with plenty of fat stores and not feel hungry. And fructose stops the brain from registering it. And it's meant to. Fructose is there to actually drive us to eat more. But this is the pathway I'm interested in. It's called de novo lipogenesis. That means that we can actually produce fatty particles within our liver from fructose. And we're going to dwell upon this one now. So there are complex pathways, but again, we're going to look at this low-density lipoprotein pathway. What happens if we increase our fructose load as our diet? Well, we end up with more LDLs, and they've got to go somewhere. And what they do is they end up in the blood vessel walls. They do that, and when they end up in the blood vessel walls, they need to be filled up with fat. They don't care where the fat comes from, and it's purely related to our diet. So if you've got a diet high in saturated fats, there'll be more saturated fat in those LDLs. If it's more in polyunsaturated fat, there'll be more polyunsaturated fat. So again, our diet reflects how much polyunsaturated and saturated fat sits in our LDLs. And again, remember, the more polyunsaturated fat we have in those LDLs, the more likely it is to be oxidised and inflamed. So if I fill up my fat in the body with saturated fat, that's as equivalent of the flammability of a brick wall. There's nothing to actually get oxidised. It's all a solid particle. However, if I fill up my LDLs with a polyunsaturated fat, that's akin to starting to build things out of dry kindling. So those LDLs sit in the blood vessel walls, and they get there in the circulation. They float around the bloodstream, and this slide, I think, tells an enormous amount. So they float along in the bloodstream, and they're circulating LDLs, and I call them the Goldilocks size because they just happen to be the right size for sneaking through the blood vessel wall. High-density lipoproteins zip in and out. They're very small. The very big VLDLs float on by. But these LDLs just happen to be the right or the wrong size, depending on which way you look at nature. And they sit in the blood vessel wall, and depending on the amount of polyunsaturated fat within them, they become oxidised. If they become oxidised, then you get inflammation in this layer. And that layer of inflammation is cleared away by the macrophages. They're a clearing cell. This is interesting for me. Vitamin D, its job is to improve the efficiency of the macrophages to clear those oxidised LDLs out of the blood vessel wall. Remember that in nature, our fructose load is in summer. And at the same time in summer, our vitamin D levels go up. So what would happen if we have a fructose load all year when our vitamin D levels go down in winter? So we've in fact inhibiting our vitamin D by getting out of the sun now, and in winter we're continuing our fructose load in the modern diet. So we're inhibiting our clearance mechanism, which nature's already provided us. Now, the cell membrane wall actually is made up of phospholipids. They're made up of fat as well. It's a major structural component of every cell wall. And again, the cell membrane wall is filled up by saturated or unsaturated fats. And again, it's just reflective of our diet. And again, we've now got the model here where our LDLs and our cell membrane walls are filled up predominantly in this society, or an increasing amount, with polyunsaturated oils, which I think are highly inflammatory. As they become oxidised, we end up with more inflammation. And that ends up with arterial wall inflammation in every blood vessel in every organ. And it also means that every cell membrane in every organ is in fact inflamed now like it's never been before. We'll come back to carbohydrate. We talk that's predominantly glucose. But I want to introduce a new topic to you. This has only recently come across my way, and it's in fact that we've come across a form of endogenous fructose conversion by a thing called the polyol pathway. Up until recent times, we've always thought, or most of us interested in this topic, have thought that fructose comes from our diet. But it's been around for 50 years, this polyol pathway, we've known about it. But 3% of the glucose you take in any of these forms actually gets converted to fructose. And that's a hidden amount of fructose that we have never known about, or not in recent times, and we certainly haven't put the two together. So you may think you're not having any fructose in your diet, but if you're having carbohydrate, you're actually having some. So we have a 3% conversion of glucose into fructose by this polyol pathway. Along the way, it also produces a thing called a reactive oxygen species. That's a highly inflammatory material which can also create more inflammation as it goes along. And again, for 3% of the glucose we have, that's a problem. However, this paper only came across my way 2 weeks ago. Back in 1984, this group led by Gonzalez were looking at cataracts, and they found a pathway there which actually suggested that in fact it's not 3% of glucose converted to fructose. In a hyperglycemic, that's a model where the blood glucose is higher than 7, not particularly high, or you're insulin resistant, up to 30% is turned into it. There's a 10-fold increase conversion of glucose to fructose. Now, in a society where we are in fact insulin resistant, obese, diabetic and pre-diabetic, it's an enormous amount of people who are insulin resistant. It's estimated that 95% of some Polynesian island nations are insulin resistant. So that means their carbohydrate, when they take it in, 30% of it's actually been turned into fructose. So therefore, where we thought that it used to be 3%, in our current society, it's actually 30%. And that increased fructose means a lot more LDL production. So in my model of modern disease, I've made an observation that for 2.5 million years we got to the top of the food chain. And in the last 60 years, and particularly the last 30 years, we've changed that diet and we're on a fad diet and we've gotten into troubles. My hypothesis, which I've said, is that the combination of fructose, refined carbs and polyunsaturated oil create that inflammatory picture. So have we got any evidence for all of this? First of all, let's look at association evidence, and I thank David Gillespie for this slide. Our fructose consumption as a society has been steadily going up for the last few hundred years, but in the 1970s, it started taking a big jump. And blue here, this is US data, but the blue here is sugar, the orange is high fructose corn syrup, and the grey is in fact fruits, is juices. So we've had a significant increase in that, and that's worldwide. It just happens to be that in Australia, that blue area extends pretty well across the orange area. So in the same time frame, 1970s, we had an increased amount of LDL production in our bodies. What's happened to carbohydrate consumption in the same time frame? Again, in the 1970s, we started kicking off with a significant increased amount of carbohydrate in our diets across Western world. What does that mean? Well, we now know about this polyol pathway, which is giving us an even greater load of LDL particles. What's happened to our polyunsaturated oil consumption in that same time frame? Here we've got vegetable oils, which is all polyunsaturated oils, again in the 1970s, taking off with an exponential rise. Red and yellow are butter and lard, and we've had a significant decrease over time. Green line is in fact margarine. Margarine consumption went up for a while and then it's come back down again. But the most important thing here is this rapid and dramatic rise in the amount of vegetable oil and polyunsaturated oil in our diet. And that's related to driving production costs down. Have we got any proof within the body? Well, Stephan Guyenet from Washington has loaned me this slide. And what he's done is looked at data which has been collected over the last 50 years. And he doesn't quite understand why in 1960 they started collecting data on the amount of linoleic acid in fat. Linoleic acid is in fact an omega-6 fatty acid. It is the pro-inflammatory one. So if we look across that whole polyunsaturated spectrum, it's the one which is associated with inflammation. So in 1960, around about 8% of our body fat was in fact pro-inflammatory. And with a change in diet, we've had a steady increase to where it's now around 2010 estimated around 24%. So where it was 8%, we've now had a 300% increase in the amount of polyunsaturated inflammatory fat in our body fat. So we increased that component. The same thing's happened in women's breast milk. This is both US and confirmed in French data in the same time frame. The amount of omega-6 pro-inflammatory linoleic acid has been steadily rising, whereas the omega-3 component, which is the anti-inflammatory one, has been staying pretty well steady. So this is what we're feeding our babies in the same 60-year period. So therefore, we're not only in that same time frame of increasing our LDL production, we've loaded up those LDLs with a polyunsaturated oil, and that equals more inflammation. We've also put that polyunsaturated oil into our cell membranes, and that's another load of inflammation. And what have we ended up with that? We've got modern disease. So if we look at that model, we have an observation, a hypothesis, and we've got evidence, and I've described what I think to be a logical and fairly simple mechanism and pathophysiology. Have we got any proof that intervention makes a difference? Well, I think we do. Low-carb, high-fat diets have been recently reviewed and shown that to have a very beneficial effect in weight loss and sustaining that, and also reducing cardiovascular risk factors. Ketogenic diets is a situation where you have a very, very low carbohydrate intake and you run on the fat fuel system, and that diet has been around in the management of numerous conditions for many years. It predates the management of diabetes with insulin. It was originally used in the management of epilepsy and is still being used in the management of children's epilepsy. There's some early good results now suggested for some cancer management by reducing that glucose load to the body. You may have heard of blue zone longevity cultures. There are several cultures around the world where they live very, very long periods of time in the 80s, 90s and 100s, and they essentially die of old age rather than modern disease. And people have looked very carefully at their diets to see what they have in common. Importantly, the common feature is that they do not have an intake of processed food. They have very low consumption rates of sugar, refined carbohydrate and polyunsaturated oils. They combine that with a very great sense of community and spirituality and generally very low stress environments. All of those factors are shown to in fact be associated with longevity. So our model of modern disease is in fact sustained across all of the parameters that we require. The combination of fructose, refined carbohydrate and massive glucose loads that we haven't ever seen before with the polyunsaturated oils combines to give us inflammation and a model of modern disease. There are other factors involved in that, and we talked about them earlier. Vitamin D, stress, genetics, chemicals, and a variety of other factors have all been implicated. What these factors are able to then have their effect on susceptible organs in the body. The moment you're under a constant state of inflammation, then you've got the susceptibility to greater disease and failure. I do think that modern food product is a weapon of mass destruction. I think modern disease is centred around inflammation. I think it's now time to start putting out that inflammation. I think the future of eating is in eating real food. I believe in having a low sugar diet, certainly a low carbohydrate one, and minimising polyunsaturated oils. I think the future of eating, it comes back to eating locally, seasonally, and natural food. I think we've been led up the wrong path for a long, long period of time now. We've been given lots of wrong advice, and it's difficult to pick through that and find the right information. But if you're armed with the right information, that the modern Western diet is in fact inflammatory on our bodies, you can start making some right decisions and moving forward with your own health. I do think we now have a nutritional model of modern disease, which is centred on our consumption of fructose, refined carbohydrate and polyunsaturated oil, which then creates susceptible organs, which are chronically inflamed and then prone to other influences. I need to thank many people who helped me on this journey. I've climbed on the shoulders of many others and been allowed to join a lot of dots together. Thank you very much for your attention, and hopefully you can consider everything in a new light and take that into your own health and well-being.